Hey guys, I'm back. Still in quarantine. Not doing the hair. Still wearing a hat. Okay, so hopefully things are going really well. I've gotten a chance to look at some of your crystals. They look awesome. The copper crystals, hopefully those are going well. If sometimes they grow awesome. Other times, if you don't get the nail right on the edge near that cotton on the side, you don't get to see the copper grow as well. But I love looking at it, and we're gonna get some people growing some really amazing ones, and we'll take a look at theirs. It's just gorgeous, and we don't process that copper can be a crystal. We think in our head, oh, it's a powder, or it's just a big solid metal. We don't really think how, well, yeah, it has to arrange in a crystalline structure of some sort. So, the big thing, and my goal for you with this part of this class is for us to understand the metals and ceramics and glass and concretes and composites, all those things that are out there, we have to understand its atomic arrangement and how that crystal is going to connect with another crystal and how the atoms grow. Growing's not the right word, but how they line up with other atoms in making that solid structure that we see. So if we don't have an understanding of that, we're going to be lost when we start to talk about metals and metal fatigue, how certain materials might fail, what that means. But it all comes back to this. Okay, so I'm in your note packet for the notebook with BP2. So the one that you got a couple days ago, I think, that looks like this in the front, has the picture of the crystal, and I'm on page 3 of this in your guided notes. Okay, so looking at page 3, hopefully that's working okay. And my goal for right now is just to get some notes in here. When we look at solid structures, there's really 3 main types of solid structures that we can look at. The first is a single continuous pattern. So a single crystalline structure, the atomic arrangement of that is a entire single continuous pattern. This is what you guys are making right now with your copper sulfate crystal, the big crystal that's hanging, or some of you did the potassium alum. But those big crystals that you're putting in the beakers, you're making and trying to grow a single continuous pattern crystal. And that's why, Mr. T is having you guys try to clean it up a little bit every day, pull it out, take a look. You want to clean up all the little crystals that are off to the side, because if we don't, we're not going to see this beautiful, big continual pattern that happens. It is really, really hard to grow a single crystal. The chaos would be, it wants to make polycrystals, mini crystals, and that's what this next one is. So a polycrystalline solid is when we have more than one crystal bonded to each other. So they're still connected, but there's a little more chaos with it. This is what you're growing with your copper in the test tube. So, and you can even see that, when you're looking at that copper, it's not this one continuous pattern. You can see how we have, and they're called dendrites that are going off to the side. And we're going to learn more about those in a future activity that you're going to do. But polycrystals is really what tends to happen. Okay, it's a little less ordered, a little less structured, and you can even see that. This would be one crystal here, and this would be a second crystal, and a third, and a fourth, and they still are connected to each other. The whole thing is a poly, so a mini crystal all connected to each other. And then the third, we aren't growing right now. It's an amorphous solid. So this would be the one type where we see no predictable repeating pattern. You thought maybe in physical science we'd call, and it's true, clay would be an amorphous solid. It doesn't have prediction in the angles of one atom being arranged to another, and we can manipulate that actually too quite a bit. So we're going to look at some examples that would be like each of these. This is when we think crystalline, this is what we think of. I had a false belief for a very long time, had in my brain that only salts could make crystalline structures, or a sugar cube could make a crystalline structure. And, you know, this class really opened up my eyes and reminded me, hey, you know, so can all the metals. How else are they going to do what they do if they're not forming a nice crystalline structure? Okay, so we got some pictures that are already in your notes. Where do we find these? So the single crystalline solid, precious gems. So, you know, boys, when you finally find that one and only, and when you give them the diamond, that diamond is a single crystal that has been created. Turbine blades have these. PET scanners, lasers use single crystals. Silicone chips, so computer chips use single crystals. And I'm going to have some videos attached to today's lesson, and hopefully you guys are enjoying those. I wish I could play them as we go, but that last one showed me that I can't. I got flagged by YouTube, so I think it'll be easier if I just add them as extra videos that I would like for you to watch, and it's going to increase your understanding of this. Polycrystal solids, it's most common in metals. So when we actually look at metals that we're growing, like you saw with the copper, those are polycrystals, which means it's also going to be common in alloys and then many ceramics as well. So when we get into talking about ceramics. Amorphous solids, we're going to see it in glass, and we maybe talked about that even in physical science, where glass is considered an amorphous solid. And also in many synthetic polymers. And remember, polymer can be thought of as a fancy name for many different types of plastics. So whenever I see you next, so when I'm finally out of quarantine, there is a demo, and I just don't want to do it on video. It's something that's kind of cool to watch in person. So I'm gonna wait and do this demo that we can actually manipulate some plastics, and they can have a crystalline structure, and then we can manipulate them with heat to create an amorphous structure, which is kind of fascinating. And we're going to do that whenever I get back. I'll show you how we can manipulate a jug of milk, like the milk jugs, and play with it going between a polycrystalline structure and an amorphous solid. Okay, so that's it. It was just a really quick lesson. You can probably I'm a little exhausted. This is crazy, but we're making it work. I thought I'd show you my buddy. I brought my friend with me tonight. Jax, you want to say hi? Oh, don't go too far, Jax. Let them see you. Now he wants to follow me. Say hi, Jax. Stay. Are you there? I can't even see what I'm videotaping. So this is Jax. I'm probably making you guys dizzy. He's my buddy. He's keeping me sane right now. Oh my gosh, Jax, you just don't walk so far. Okay, all right. I'm sure you guys are absolutely bored. Hope everything's well. Take care. We're heading out. Peace out.